Okay, let's go ahead and start chapter 4, section 4, which is covering a little bit more with exponents. We're talking about fractional expressions with exponents especially. All right, so part 1 using the quotient rule. What we've got going on here is with the quotient rule, you're essentially subtracting, you're finding the difference of the exponents. But here, let me write this down. So you got find the find the difference, subtract of exponents with like bases. So it's important that they have the same base. X's with other X's, Y's with other Y's, R's, S's, whatever the letter is. C's, like a number, on an example E. So yeah, so what you're doing is you're just finding the difference. You're subtracting them. So in example A, you're going to subtract these. 8 minus 3 is 5. All right, and so that's going to be n to the 5th, n to the power of 5. Okay, right here, we just got kind of a mix going on. All right. Now, one thing that, now we really haven't officially been introduced to negative exponents, so I don't want to talk about those yet. All right, but let's just kind of talk about what's going on here with the x's. Now, you'll notice that there's more x's in the denominator than there are in the numerator. Therefore, that's where they're going to stay. Now, you're probably not going to want to do this every time there is an exponent problem, but I think this kind of makes it clear when, well, like what happens to the powers, what happens to the exponents. So if I were to expand this, I'm going to write a lot of x's here, but so you got 9 x's, and we have 3 y's down there. And if we just start canceling them off, right here, this cancels off with this, right? Just kind of doing a one-to-one here, those x's. So we don't have any more matching x's to cancel. See that? All right, so this y cancels with this y cancels. All the y's actually cancel. And all that's left here is, what do we have there? 7 x's. And nothing appears to be remaining in the numerator, but we can't just leave the numerator empty, right? We just can't do that. There's always a 1 up there. So the default number that we can keep up in the numerator is a 1. In the denominator, we have x to the 7th. All right, so you have to write it like that. All right, I think the most common mistake people do is they just write x to the 7th because that's what appears to be remaining, but that's, that is true, but there were 7 x's in the denominator. We have to keep something up in the numerator. So this is not true right there. Okay. Now, yeah, expanding it all out, especially for exponent problems, it definitely makes it make more sense, but it's not a realistic or pragmatic way of kind of doing this. I think just thinking of it as differences is probably going to be easier for you. So like right here we have 1 7 in the numerator. We have 2 7's, with the base of 7 in the denominator. So this one cancels and that 2 goes away. Right here, 10 minus 6 is 4. All right, and so this goes away. All right, 0 minus 4 is 4, right? Well, I mean, it's actually negative 4. But we can get rid of that s right there. And so all that we're left with is we have r to the 4th in the numerator, and we have a 7, and then we have s to the 4th in the denominator. That's it. We can't do any more with that. Okay, right here, we have 11 and we have 8. So we should subtract those, right? 11 minus 8 is 3. All right, but you should probably be saying, like, hold on there, which is true. What am I doing wrong? Hopefully you're seeing this. Well, we don't have like bases, do we? We don't have like bases. This is a 7, obviously. This is a 9. We can't do that. We can't do any subtracting of power. So we just have to leave it as it is. Just leave it be. That's it. That's what it's going to keep. It's going to stay as 7 to the 11th power over 9 to the 8th power. Right here, both of these are the same. They cancel off. They turn into 1. Basically, 1 over 1 equals 1. All right, so that is quotient rule right there. Quotient rule is just where you're subtracting the powers. And the important thing with quotient rule is that you're subtracting powers with like bases. Very important to do that. Okay, for part 2, raising a power to a power, if you're doing that, what you're going to do is you're going to multiply. Multiply the exponents and keep the base. All right, you're going to keep the base. So like right here, x to the 4th to the 7th. Now you notice like there's another power right outside of the parentheses. So that's an indicator that you're going to multiply. That's really x to the 28th. Right? And again, I could expand it, and you're not going to want to do this every time, but like this basically means x to the 4th times x to the 4th, 7 times. So we can just keep doing this. All right, and then if you expand it, then you can kind of think, well, I can actually use product rule, which is where you just add the powers, right? 4 plus 4 plus 4 plus 4, 7 times. But, as we discussed in a way earlier lesson, chapter 1, yeah, multiplication was invented so that we did not have to repeatedly add up numbers. So yeah, 4 plus 4 plus 4 plus 4. Much easier to just do 4 times 7, isn't it? It is. Okay. All right here we have 5, and then we have a 0. Now 5 times 0 is 0. So you got m to the 0. Now anything to the 0 power is 1. Anything to the power of 0 is 1. Okay. All right. So to raise a power of power, raise each exponent. Oh, let me do this. Raise each variable to that power. Now, I'm going to kind of use the word distributed, but it kind of feels like distributed property, but it really isn't. But I mean, you kind of almost want to think of it that way. So right here we have a 2, and we have a couple things inside the parentheses. We have a 4 and we have an x cubed. Right? So that 2 has to be applied to both the 4 and the x cubed. All right? Not just this part, because that's a lot of times that's the most common mistake. They'll just do it to the part that's closest to it. But we want to apply it to everything. So it's really going to be 4 squared, and then you're going to do x cubed squared, which is 6. All right, and then we can clean this up a little bit. That becomes, what, 16? X to the 6. Right? Remember, this 6 has nothing to do with this 4. Right? It has to do with the x. Right? That's what it is applied to. So 16 x to the 6 is it. All right here, we've got a 5, we have an A, we have a B, and a C. So there's 4 things we need to apply the 3 to. We need to apply it to the 5, we need to apply the exponent of 3 to A to the 4th, B to the 9th, and the C. Okay? So you're going to do that. Now, C to the 0 is just 1. So we can just kind of, we can just get rid of that. We don't even really need to think about that anymore. So what do we have? We have 5 cubed. All right. A to the 4th cubed is going to be basically 4 times 3, which is 12. We have b to the 9th cubed, which is going to be 27. And we already took care of the c. So that's it. And we could probably deal with that 5 cubed. Now 5 cubed is just 5 times 5 times 5, right? 5 times 5 is 25, and 25 times another 5 is 125. So this all comes out to 125, a to the 12th, b to the 27th. All right, next page, let's go through part 3. So using the power rule with fractions. All right, so the notes say, if a fraction is enclosed in parentheses, apply the exponent Okay, so we're going to apply the exponent to power, right? We're going to apply the exponent to every part of the fraction, to each part of the fraction. So again, it's going to feel like distributing. It technically is not that, but I almost I don't want to say distributed property, but I mean it feels like it's just, but it's not. So we're going to apply this 3, the exponent. That 3 is going to be applied to the numerator and the denominator, right? Not just because I know it looks like it only is up top here because that's how powers are noted, but it's outside the parentheses, meaning the whole thing is affected by it. The whole thing is affected by it. So this really becomes n to the third, right? And then you have 4 squared cubed, which is 4 to the 6th, right? We can leave it that way. 4 to the 6th. What is 4 to the 6th? I'm gonna write that. I'm gonna work that out. So the 4, that's 4,096. All right, same kind of example here. So you're just going to apply the 2, the exponent of 2, to the numerator and to the denominator. All right, so what do we get? We get x squared over 6 squared. And we can clean that up a little bit more. X squared over 36. All right, so part 4, mixing it up. All right, so we've got kind of a bunch of stuff that we've been learning about exponents here, all kind of mashed together. So let's kind of just go through these one by one. It says, look at each expression carefully and decide which property you use and simplify. So on this one right here for A, we're not really using any exponent properties for this one. These are just like terms, okay? That's all you can do. We can't really do anything. We can't do anything to the exponents. So those are just like terms. And so that 13 plus 9, we're just going to add the coefficients. We're not going to do anything to the 5, to the power of 5. So 13 plus 9 is 22. So you got 22x to the 5th, and that's it. That's all you can do to that problem. All right. Now this one right here, now we're multiplying like bases. All right, where we have x, right? We have an x there. And so we're going to use the product rule. And with the product rule, what do? We add exponents, right? I'm going to abbreviate there, but add the exponents. So we're going to still, though, like when it comes to coefficients, we're just going to multiply them. So 12 times -6, that is -72. So you got -72 there, and then treat the powers. We've got x cubed, and we've got x to the 7th. So we're just going to do 3 plus 7, which is 10. So you got x to the 10th power. That's it. Okay. Now right here, we're going to do, and actually I don't think you can give it a name, but I call it power to a power, but it's actually called power rule. And with the power rule, what we do is we multiply exponents. So that is what we're going to do on that one. So we kind of just talked about this. So this 3 is applied to the coefficient of 3, and it's also applied to the x. So we've got 3 cubed, and then we have x to the 5th. Now when it comes to this right here, we're going to multiply the exponents, so it's going to be 15. And then we can work out the 3 cubed. 3 to the 3rd power is 9, right? 3 times 3? No, it's not. It's 27. 27 x to the 15th. That's all you can do for that one. All right, this one right here, we're going to use the quotient rule. So we're going to subtract exponents. That is what we're going to do. We subtract about, and then when it comes to coefficients, right, we kind of treat those just like regular numbers, which they are. All right, so we have 156 over 144. So 100, I think those divide by 12, right? Yeah. So 156. Ooh, 156 divided by 12 is 13, isn't it? It is 13. So I'm going to put 13. 12, or 144 divided by 12 is 12. So that becomes 13 twelfths. All right, and then F, so we got 9 and we have 7. So 9 minus 7 is 2. And there's more F's in the numerator, so that's where I'm going to keep them. There's more H's in the denominator, so we'll keep those down in the denominator. How many more H's we have? We have 4. 15 minus 11 is 4. And that's it for that one. And this one right here, we're just going to do, this is just power rule, right? And we're just going to do n to the third, and then 8 to the third. So that's what you're going to do to get that one. So 8 to the third, what is that, 512? I think it is. Yeah, 512. So you got m cubed over 512.